So welcome students. So in this question you are asked to find the asymptotes of this hyperbola xy minus 3x minus 2y is equal to 0. So what are the asymptotes of this hyperbola? So what is the logic that we use? So you have a standard statement in hyperbola which says that the equation of the hyperbola and the equation of its corresponding asymptotes differ only by a constant. The equation of the hyperbola and the equation of the pair of asymptotes differ only by a constant. That means, so I can assume the pair of asymptotes, can be assumed as xy minus 3x minus 2y plus lambda is equal to 0. So let this be the pair of asymptotes. Now what should be the value of lambda so that this becomes a pair of lines? So a pair of asymptotes is by nature a pair of lines. So if this equation should represent a pair of lines, it cannot happen for every value of lambda. Lambda has to be a particular value so that this becomes a pair of lines. So what is the value of lambda which ensures that this is a pair of lines? So for that we know that you have ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. If the second degree general non-homogeneous equation has to represent a pair of lines, then delta has to be equal to 0. That is, determinant of a, h, g, h, b, f, g, f, c has to be equal to 0. So now this is the general condition for this general equation to become a pair of lines. So now what is the condition for this to become a pair of lines? According to this, so a is equal to 0, b is equal to 0, h is equal to half because xy coefficient is 1, 2h is equal to 1, h is equal to half, and 2g is equal to minus 3, so g equal to minus 3 by 2, f is equal to minus 1, c is equal to lambda. Now if you substitute this, so 0, half, minus 3 by 2, half, 0, f is minus 1, and lastly minus 3 by 2 minus 1 lambda has to be equal to 0. So if this determinant is equal to 0, then this equation represents a pair of lines. So now we can solve this. So to remove the fractions, I will multiply 3 rows with a half. Doesn't really affect the 0 because even if you multiply 0 with 3 halves, you get 0 itself. So implies determinant of 0, 1 minus 3, 1, 0 minus 2, minus 3 minus 2, 2 lambda is equal to 0. This implies minus 1 times 2 lambda minus 6 minus 3 times minus 2 is equal to 0. So 2 lambda minus 6 is equal to 6, 2 lambda minus 6 is equal to 6, 2 lambda is equal to 12, so lambda is equal to 6. Lambda is equal to 6. So you just need to substitute lambda here. So lambda is equal to 6 and this becomes a pair of lines. Once this is a pair of asymptotes, you can just factorize this to get the actual asymptotes. If you factorize this, you get x times y minus 3 minus 2 times y minus 3 is equal to 0. So y minus 3 times x minus 2 is equal to 0. So y minus 3 times x minus 2 is equal to 0. So one of the line is y is equal to 3, the other line is x is equal to 2. These are the pair of asymptotes. Thank you.